Hi, everyone, and welcome to 1337's Knowledge Stream today. My name is Sarah, and I'm a consultant manager at 1337. With me today, I have Matej from our office in Slovenia. Hi, Matej, how are you doing?
Hi, Sarah. I'm doing fine. And for your side?
Yes, I'm great, thank you. The sun is shining and summer feels like it's just finally arriving. As you told me a few minutes ago, I can't wait either to just go outside and enjoy it a little bit.
Yeah.
Before we start with today's session, I just want to let you guys know that if you have any questions, please let us know in the comments and we will go through them at the end of this. And as all the other streams as well, this will be available on our YouTube channel. As you might know, since before, knowledge sharing is very important to us, and these knowledge streams gives us the opportunity to keep doing so, even though we can't do it in physical form just yet. So make sure you like, follow, and subscribe to not miss out on any of our upcoming knowledge streams. So that was all the information I have on that. Enough for me. Matej, I think you're ready to talk to us about using raw data to make better decisions. So please take it away.
Yeah, thank you very much, Sarah. So yeah, like Sarah explained, today we'll talk about analytics in general and how, let's say, to extract value from these big amounts of data or even small amounts of data. So we'll try to touch on, let's say, on this topic. But maybe before we start, maybe I can tell a little bit about me. So I really like to work with data. Let's say my career somehow started, or let's say interest in data started somehow at the university. And I'm really grateful here to Professor Brodnik that gave me the opportunity, let's say, to work on a thesis that was touching the topic of scheduling in Hadoop environments. So this is somehow the start, let's say, of my career in this space. And after, let's say, the university, I really liked, the wish was somehow to be in this industry and somehow follow, let's say, the path of data integration, data engineering. So I have picked, let's say, a company here in Ljubljana that was specialized in data warehousing and business intelligence. And as CRMT, I was primarily at the beginning working in this space and gathering knowledge about how to build data warehouse environments, especially in the telco and insurance industry. But later on, I have been focusing more on, let's say, on analytical databases and, let's say, big data distribution. So I was mainly working with analytical database Exasol and MapR. So that was kind of my focus, or distributed environments and how to, let's say, leverage those kinds of infrastructure to let's say, to prepare data there and gain insights from there. And yeah, just last year, I think in January, I joined Threat and Dirty Who. And now I'm, let's say, helping, at least trying to help our product team that is working for, let's say, a larger retailer. I'm trying, let's say, to help, let's say, our development team and our stakeholders at this retailer to get, let's say, data in shape. I'm happy with architecture, engineering, and then building, let's say, dashboards on top of it. And yeah, and otherwise, I try to, let's say, spread the knowledge of data and data management in our company as well. And yeah, this is, let's say, one of the talk, let's say, that I'm having just right now. So there's just a brief introduction about me. I really like to work with data, and regarding this talk. If we take a look at the agenda, so in analytics environments, or let's say in data management, there are quite a lot of things that are that should be covered. But in this talk, we will at the beginning we will focus on trying to somehow define what data analytics really is. Then we will move to defining, let's say, those environments. We will see that oftentimes analytics environments are separated from operations environments. After that, we will touch, let's say, common questions that we are covering in a typical, let's say, data project. we'll not go really into details, but we'll try to describe, let's say, the common steps in data projects. And then it really depends on the time that we will have, but in general, we'll touch different analytics role, or let's say different roles that are involved in data projects. Then we will touch a little bit about the data architecture and modeling. So this part is mainly how we structure our data in our environments. So they are, let's say, easy to maintain and easy to use to the final consumer. And at the end, we will touch pipeline, so data pipeline development, which is somehow one of the crucial, let's say, activities that we're oftentimes seeing in these environments. And in data pipeline development, we will see that it's not just one transformation that solves all the problems, but we will see that if we want to have, let's say, a really organized environment, we must, let's say, take some good approaches from pipeline development that we can oftentimes find in data warehousing. So this is the brief agenda that we'll try to cover today. And if we start just by trying to define what data analytics really is, let's say it's a term that the industry, I would say, haven't settled down really. But yeah, we can define it in different categories. So we know prescriptive analytics, we know descriptive analytics, we know predictive analytics. So we're having a bunch of, let's say, those terms. But if you want to really simplify this definition, I would say that it's just a set of processes that are helping us to extract value from data. And I think that with this definition, we are somehow covering all of the activities that we find in these analytics environments. And this is covering, let's say, the processes or, let's say, activities that we find in data engineering side of it. So on the side where we are preparing and extracting data from source systems, and it's somehow covering, let's say, the activities that we have in let's say, business intelligence, let's say, business intelligence departments, or in data science activities. The main goal is that we're doing all of those activities because we want to have an overview of our data, and we want to extract some meaningful value for our company or our enterprise. So so if we just, let's say, maybe see what is the final result of these activities, we can maybe check, let's say, the next example. This is an example for the Zebra BI, which is a BI tool that is oftentimes used in business intelligence, let's say, scenarios. And business intelligence is somehow, from the departmental view, these departments are, let's say, I would say, quite common, let's say, in bigger enterprises, and their role is to support, let's say, business stakeholders, so they can answer, let's say, the questions that they are having regarding different operations and company performance. And in this case, we can see an example of a dashboard that is describing the sales performance. And the main, let's say, the main thing that comes out from this visualization is that based on this graph, based on these charts, let's say, business analysts can then see that something is wrong, let's say, with a specific region, and then they can make, let's say, a further action based on this view. So let's say for this artificial, let's say, example, we can see that in Poland, let's say, if you compare the previous year revenue to the actual one, we can see that there is a drop-off. And maybe based on this information, we can take, let's say, further steps, or let's say we can decide on the next step what we should do. So I don't know, maybe we should increase the marketing activities there. Maybe we can replace some products that we are selling there, and so on. So this is, let's say, one of the quite common example that we see in let's say in bigger companies. So this is an example from BI, and the next one is an example that I think that all of us know, and this example falls into the section of more advanced analytics. And with Amazon, you could probably see that when you're selecting a certain book, there are some suggestions that you can click then. And this is another example, let's say, how analytics is making those decisions of what to buy a little bit easier for you. So in this case, if we will select the Kimball Data Warehouse Toolkit, we would be, let's say, the algorithm would suggest us to maybe look at the Star Schema book, and then we can maybe buy this one as well. So it's helping us, let's say, to somehow broaden our knowledge and suggesting us additional, let's say, books that we didn't even know that existed. So this example from analytics falls, like I said, from into the bucket of advanced analytics, and maybe the last example falls maybe in the category of consumer. I would say consumer analytics, and this one is quite close to me. And it was quite interesting to me to see that we are having now, let's say, companies that are using analytics even, let's say, on coffee machines. And one of these examples is the decent espresso machines. Unfortunately, I'm not yet an owner of this machine, but it was quite interesting to see that analytics is coming into this space as well. And on a tablet, like you may see, we can see several, let's say, attributes. We can see what is the brewing time, how much we have been brewing the coffee. We can see what is the pressure at a certain point in time. We can see what is the temperature. And this kind of information are there, let's say, to help us make a better coffee. So if we see, let's say, if the pressure at the 15th second would raise, this would probably mean that our coffee will not be so good, because most probably we're having channeling in the coffee pack. So that means that maybe for the next step we should grind the coffee beans coarser, or maybe we should lower the pressure, or maybe we should take some other kind of action. So this is an example on how, let's say, analytics, let's say, principles are coming into the consumer space as well. So all of those three examples, if we try to somehow find out the common denominator between all of those three examples, I would say that on one side, analytics is helping us making better decisions, but on the other side, analytics reduces the number of decisions we have to make, and this is especially true in the case of advanced analytics, when algorithms are making decisions for us. So this is, let's say, just for the intro, but all of the cases that we have seen are just the final step in the analytics process. So all the visualizations, all the machine learning models, all the other statistical models that we do are just the final step in this data journey and data environments. And now we'll somehow try to describe a little bit more about how those environments looks like. Like I mentioned before, we're having two types of systems. So operational systems are trying to support our daily operation, our business operations on a daily basis. So this is an example of a web shop, or maybe this is an example of a CRM system, so customer relationship management system. This is maybe a software that we build for our customers, regarding some kind of task management, and so on and so forth. So these are the operational systems that are not meant for analytics. We can do, let's say, some kind of aggregation and queries on those systems, But the thing is that the purpose of those systems is quite different than the analytics one. And the thing is that those systems are specialized for a certain type of workload. Whereas in an analytics environment, we're oftentimes scanning whole data sets. So I don't know, if we have a web shop, we typically like to analyze all of our data from the previous year to find out how well we performed. And if we would run, let's say, this kind of queries on directly on a database from a web shop, we will probably make this system unavailable, or at least, let's say, making it slower. So this is let's say, one of the reasons why we are having, let's say, those systems separated. There are some, let's say, trends that are where those two systems are merged together, but I would say that maybe the majority of cases that we see in the data industry are having those systems separated. But it's not just about the separation. So when we're having, let's say, our analytics environment, the thing is that this analytics environment can get quite messy. And if you're not having, let's say, a more structured approach to data management, how we manage data, how we transform data, how we conform data, then probably our project will not be really successful. And let's say from the last 20 or 30 years, there are some established practices that we can follow, and I'm referring here especially to the data management framework, which is somehow, I would say, let's say, a framework or some guidelines on how to operate and organize these kind of environments. And this framework is not really touching just the technical side of it. So what should be the architecture? What infrastructure should we choose? But it's touching also on the side of on the organization perspective and data governance. So in this framework, we can find, I would say, practices and standards on how to really build robust and reliable environments. And if I would have to choose, let's say, two main functions from this, let's say, framework, I would maybe choose data warehousing and business intelligence and data science. And I think that, let's say, practices from those two areas can be oftentimes found in analytics environment. And it's quite important that we maybe use this kind of practices, because then the success of the project will be probably higher. Data warehousing and business intelligence, in a really simplified or layman terms, are just, let's say, a set of practices on how to consolidate, or let's say, bring all the data together in one place, in one central repository, and to conform this data in such a format that an analyst, when he or she sees this kind of information, he can easily somehow analyze all the information that are stored in this analytics environment or data warehouse. So the main goal here with data warehousing and business intelligence is somehow to sync all the departments together regarding the same definitions, and then conform this data on a common denominator. So we can, let's say, for example, we can analyze performance of a web shop with a performance of a physical shop together, even if they are having different, let's say, systems that are supporting these activities. And we can find a lot of good practices in this segment. And data science, it's kind of the hot topic in the last years, and it really provides, on top of business intelligence, it provides, let's say, additional insights into data, and it brings, let's say, the information or value that a human eye can see. So this is just a simplistic way on how to see data science. It's a set of, let's say, algorithms, machine learning techniques, statistical modeling, and so on and so forth, that are helping us, let's say, to extract some patterns that can be extracted with typical, let's say, practices from business intelligence. So these are, let's say, the two most important, I would say, areas from analytics environment that we can use. But if our organization is let's say a bigger enterprise, then other aspects of data governance, metadata management are becoming even more important. And data quality is one of, let's say, the things that we always should be careful about. So we mentioned before that those two environments are oftentimes separated, and there are several reasons for that. I mentioned before that the purpose is different. This is one of the main drivers. So operational system, the purpose is to support, let's say, the application that is running on top of the database. And typically we are fetching, let's say, if I take the example from before, from a web shop, typically those kind of systems are making queries to our databases and returning just maybe one record or few records, but never, let's say, are returning, let's say, a really big number of records. Whereas in analytics environment, we're trying to do the analysis holistically on the whole data set, and the workload is really different. And like I said before, if the workload is different, the optimization techniques inside the databases are different. This is one of the reasons. The other reason is that typically operational systems are not tracking history. So we are having an update field, but typically those information is not tracked in operational systems. Whereas in analytics environments, we oftentimes want to have this kind of information stored, so that we know that we can go back in time to see what was, let's say, the current state of data at a specific point in time. And this is not possible in operational system. At least, let's say, this would make them slower and not so performant as they are. And if you're using, let's say, NoSQL databases for our application, the thing is that they're even lacking, let's say, some aggregation framework that would enable us to make, let's say, some aggregational queries on top of those systems. So these are, let's say, just a few of the examples why those environments should be separated. Okay, so if we touch a little bit about the processes. So we told that those systems are separated, but what really happens, let's say, in those environments? And on the right side, we're having the data consumer, a user, but the first step is somehow to extract the data into those analytics environments. So this is just, let's say, just the extract phase. And when we're having data in those environments, we're having tons of processes there. So we're having processes from data warehouses like transforming, cleaning, conforming, and then we're having also, let's say, processes from data science or machine learning. So we are training our models, we are validating those models, and then we're building the infrastructure that are supporting these models to be in production. So there are a lot of, let's say, activities that are going on in analytics environments, but the main, let's say, goal is somehow to provide clean data so that the user can consume it, and the user can consume it in several different ways. So we can see that the user can access it via different protocols, via different applications. But on the other side, oftentimes we can see that those analytics insights, let's say, for example, are returning back to operational systems. So some kind of aggregates, some kind of, other kind of information are sometimes even coming back to operational systems. So this is the consumption, let's say, line that we can oftentimes see. So on the one side, we're having the consumer, and on the other side, those let's say, final result can be loaded back into operational systems. So this is just a brief overview how to position, let's say, all those different entities in analytics environment. But for this talk, we will focus mainly on analytics environment. So if you take a look at, let's say, at a typical analytics lifecycle, we can see that we are oftentimes facing the same questions over and over again. And let's say at the beginning of the project, it's really important to really tackle down and define what we would really like to solve. What is really the problem that we're trying to address? And the output, let's say, of this business requirements definition are the non-functional, most usually are the non-functional requirement and functional requirement. And those two are then driving, let's say, the whole let's say, system architecture, data architecture, what we need, let's say, from the modeling perspective, which data do we need, where should we find this kind of information, and so on. So business requirement definition is somehow the first step. It then really depends on the project, on the project that we're having, but this is the first step. Then when we see what we want to, so when we define the problem, then we can see who should help us. We'll see different roles here. We can define the system architecture, so which analytic databases we should use. Should we use a messaging system? Should we use just files and a machine learning framework? And after we decide on the let's say, on the technology, then we can go into the next step, which is data architecture and modeling. And in this let's say step, we're defining, we are structuring our analytics environments. We are making a logical structure, and then we are mapping, let's say, this logical structure to the infrastructure, let's say, to the technology that we have chosen in the previous step. And then at the end, we are having, so at the end, when we, let's say, structure our data environment in different stages, then we are ready to implement those data pipelines that are filling data into those data models. So today we'll cover the data role, system architecture, data architecture, and modeling. Unfortunately, I think that pipeline development we'll have to cover it next time. And in general, with data roles, we can see that in analytics environment, we're not just having one role. We're not just having, I don't know, for example, a data engineer that is doing all the work, but typically those roles are divided to separate, let's say, roles. It really depends on the size of the project, but typically we're having a data analyst and data scientist that are closer, let's say, to the business side of it. They are, let's say, tightly collaborating with business stakeholders. So finding what we really like to discover, what is the problem, how we should solve it. And then when we are, let's say, moving to the engineering side of it, we're having a data architect that I would say is maybe, yeah, it's a senior data engineer and he's having or she's having some kind of a broader overview of the whole architecture of the company, on the operational system and on the analytical ones. And here is important that let's say that he knows about, she knows about the technologies, what are the limitations of the technologies, how we should put all those, let's say, technologies together, and so on. So more a holistic view about the architecture and how should we design our environment. Whereas data engineering role is more concerned, let's say, on preparing the data, on cleaning the data, especially building data pipelines. This data engineering role is oftentimes, let's say, quite similar to software engineering, to a software engineer role. And in a lot of companies, we see that those two roles are somehow interchanging. But otherwise, in analytics environment, we oftentimes see the need to build, let's say, some additional software around data, like I would say some metadata catalog, some web portal with exposing this metadata, and this is where the role of a software engineer is really important. So we're having a software engineer in data ops. Yeah, without data ops and good DevOps practices, yeah, the whole project will be more difficult. So data ops is somehow enabling the work of all other, let's say, roles that we have in those environments. This is, let's say, a little bit breakdown of what each role is delivering. So we will just skip it, and maybe the next thing, let's say, in this life cycle process, we mentioned that after we know what are our functional and non-functional requirements, then we should pick up the technologies that we will use in our environments. And this is quite a crucial, let's say, step. So the technology is most of the time driven by those requirements for the business. And in most simple cases, despite we are talking about analytics environment, in a lot of cases, a typical relational database will be just good enough, especially if you are not having, let's say, really big amounts of data and a lot of users. So we can maybe start on a typical relational database, which is row-oriented, and maybe if our needs increase, let's say if our data is increasing, or maybe if we are adding a lot of columns to a table, then those row-oriented databases will most probably become a problem. But it was really interesting to see that even these row-oriented databases, which means, so the definition of a row-oriented database is that the physical layout of data on the storage is stored in a row. So we are not storing in columns, but we are storing our data in rows, and this will affect, let's say, the workload that we are having on top of this database. So row-oriented databases are commonly used for operations, let's say, activities like having a web store, and not for analytics. But just recently, we have seen that vendors and the open source community have developed columnar extensions to these databases. So we can have, let's say, both type of workloads on those kind of databases. So in Postgres, there is a CStore extensions that makes it possible, let's say, to store this data in a columnar format, which means that the performance on this columnar format will be a lot faster than if you're having, let's say, our data stored in a row-oriented fashion. And if let's say if a standard relational databases are not meeting our needs, then we can switch to relational databases for analytics. We oftentimes call it analytics databases, and the main thing is that these analytical databases are column oriented, and every optimization that we see in those environments stems from the fact that they are column oriented. So we are having vectorized processing, which is reducing CPU cycles because we are doing a single operation on multiple, let's say, data. We're having a really efficient schemes like run length encoding, bit mapping, and so on and so forth. And one of the important things is that those databases for analytics are really optimized for parallel and distributed execution. So this means that not only these kind of databases are let's say, installed on a cluster of machines, But even on a single machine, they're optimized to do the parallel workload. So they're using all the cores from the CPUs to accommodate, let's say, the query that we have triggered on a database. Whereas, let's say, in relational databases, row-oriented, let's say, stores, a query will, at least from what I know, the queries will run on a single core, which means that we will not, let's say, have such big performance boosts. So parallelization and distributed execution is a crucial factor in those databases for analytics. But if and relational database for analytics are covering most of let's say our company needs. But if we need, let's say, additional, let's say, requirements of streaming data, maybe directly accessing raw files, or maybe accessing, let's say, streaming information. So if you have a need, let's say, to have the information available just a few seconds after it's created in operational store, then maybe we can look at the concept of data lake and lake houses, where we are having all those, let's say, technologies, let's say, bundled in those data lakes or lake houses environments. So these kind of environments are supporting, on one side, they are supporting SQL access, on the other side are supporting direct file access, streaming access, and we can see a lot of, let's say, so we can see a lot, not a lot, but there are machine learning frameworks that in those environments as well, that can help us, let's say, analyze and find insights in our data. So we have touched, let's say, a little bit about picking the correct, let's say, technology or correct platform, but this is just, let's say, the halfway there. So after the selection of the correct platform or technology or infrastructure, then it comes the question how we should organize data in those environments, and we can see that in the last 20 years, a good practice is to somehow form or, let's say, separate data in two different areas. So from the Kimball approach in data warehousing, we're having two different areas. One is the presentation area, and the other one is the staging area. And the main differentiation is that the presentation area is representing the curated data that can be easily, let's say, exposed to the end user. Whereas in the staging area, we're having a lot of raw data sets, or a lot of maybe files, and we're having, let's say, stage tables that are not really, let's say, meant for final consumptions, but are meant for consolidating data together, conforming data, cleaning data, and so on. So this is the staging area. We call this area a back office area, and it's not meant for final consumption. But there are some cases, let's say, like data science activities that maybe we should, let's say, bring data scientists in this area as well. But it's quite hard, let's say, to reason about data in these environments. And if we try to map, let's say, these two areas onto technologies that we have picked, if we have just analytical database, it's quite simple. So we can just map those two areas in an analytical database, like, I don't know, in BigQuery, we're having those areas separated, and this is how, let's say, we make the distinction between curated data and uncurated data. But if we're having, let's say, like mentioned before, if we have other needs, let's say, for streaming data, or maybe a need for directly accessing files, like it's typically seen in data science environment, then maybe we can embrace the data lake approach, which means that before let's say, loading data to the presentational area into our analytical database, we can maybe have our data stored in a data lake. So all the raw data is here. Then we're doing all the cleaning stuff here in a data lake. And just, let's say, before So when let's say the data in a data lake is cleaned and prepared for usage, then we are pumping this data analytical database. And the reasoning behind this, so we could maybe have just a data lake for the both areas, but the thing is that analytical databases are really mature in this aspect, and performance-wise are let's say are more performant, let's say, than let's say distributed SQL frameworks on top of data lakes. So typically, let's say if you're having a lot of users and we're having a lot of reports to be done, typically the presentation area, we put presentation area on top of the analytics database. And there is another let's say approach that just emerged recently, and this is the lakehouse approach. And with the lakehouse approach, I would say, so data lake is having, let's say, some issues, especially on concurrency and writing files. And lakehouse is bringing to data lake environment ACID transactions, which means that it's bringing, let's say, this ACID functionality. The data is not corrupted. I don't know if we are having two users that are writing data into the same file, the data will not get corrupted because we're having this ACID compliance in place. And it will be really interesting to see if lakehouse is could, let's say, not replace, but if lakehouses will be enough, let's say, for all our company needs. And the company behind this is Databricks, and a lot of, let's say, solutions they are building is open source. So yeah, they're having a lot of, let's say, engineers and communities quite vibrant in this space. So it will be really interesting to see how this paradigm would evolve. So we have defined, let's say, how we should structure our analytics environment. So staging area and presentation area, but then we have to still shape, let's say, this kind of information. And let's say one of the most common schemes from dimensional modeling is the star schema. And the main point, let's say, of modeling data is in the star schema is to simplify access to this kind of information. So in the operational system, we are oftentimes having a lot of tables in a normal form, which means that we're having a lot of joins, a lot of tables. And the main goal of modeling data, especially dimensional modeling, is that we're having somehow a really easy to understand model, so that the end user can easily access this information and analyze this information in a straightforward way. We're having a lot of other, let's say, types of modeling. So an upgrade to star schema is snowflake schema. Then we're having data vault modeling that is somehow not defined, let's say, model exposed to the user, but we typically combine it with the style schema. And it really, let's say, depends on our needs. If we are working in a really agile environment when we are having a lot of, let's say, changes, then maybe we can think on the underlying model of data vault. But otherwise, yeah, star schema would be probably a good approach to data modeling. So we are running out of time, but let's quickly check in the next 5 minutes the pipeline development. So in the previous step, we have defined how the end, let's say, tables should look like. And now the important part is how we should load those kind of tables. And we can see that from this artificial example, we can see that there are a lot of steps, so let's say, till when we prepare the data to be ready to be loaded into the star schema. And we can see that we're having, a lot of cleaning steps, a lot of conforming steps, and then at the end there comes the loading. But it's really important that we build those pipelines in a robust fashion. And I don't know if loading a product dimension fails, then it's really important that we are not, let's say, starting the whole process from the beginning, but that we start, let's say, the process from the failing step forward. And this is somehow making our development environment quite complex. And for these purposes, we are having different approaches how we can tackle, let's say, development in these environments. But the main thing is that we're having a lot of interdependencies, and we should somehow handle those dependencies in an easy manner. And we have a lot of, let's say, no, I would say that we are having 4 different approaches how we can tackle, let's say, those management of those steps or transformations. Let's say the first one is just to build a custom framework, and this is probably the first step that when we are faced with a data project with FinGov. And it's just I would say it's a really good approach, let's say, to start simple, having maybe just one main script that is orchestrating and organizing all those steps. And maybe, yeah, at the beginning it's quite a good way to go. We can develop those let's say, this custom framework in different languages, Python, Java, Go. It really doesn't matter. Let's say the most used one is, at least in data engineering, is Python, but we can build it even in Bash. So we can build a custom framework, but we have to know that if we are going into this route, we will have to support a lot of activities. Like before, I mentioned what happens if steps fail. So we should build somehow the framework that support this resumability of the pipeline. Then we should build, let's say, some kind of a centralized logging. We should build then the monitoring of those pipelines. So there are a lot of, let's say, things that we should cover in this framework. And it somehow, with let's say, with more sources, it can get quite complex. So I don't know, for 5 or 10 pipelines, it's maybe good enough, but then we should maybe think of a different, let's say, approach. And the open source community in the recent years has provided us a lot of, let's say, good solutions that are a little bit more complex than building maybe a smaller solution in a custom framework. But Airflow somehow is the go-to orchestration tool. It's a little bit harder to maintain and to, let's say, to include in the CI/CD, let's say, style of development. But otherwise, a lot of companies is using Airflow for the orchestration of their transformation, and it's quite a, let's say, popular orchestration framework. And then another popular approach is to use integration tools. So we're having tools like Talent from the open source side of it, are Talent, Pentaho, maybe there are some others. And then on the cloud, we're having cloud native, let's say, integration tools, Matillion 5 transit stream sets. And these tools are mostly visual-based integration tools, which means that we're having in the center, we're having a canvas on which we put all of these different steps. And the good thing is that when we are, let's say, working in a group, the transformations are really clear what they mean, because we're having the pipeline visualized, and it's really easy, let's say, to reason about those transformations. And the other thing is that in those environments, we're having everything that we need, let's say, in one screen. So we're having at the center, we're having this design canvas. On the left side, we're having all the meta information about our jobs. We're having then all the information about our sources, and all the information that we need for building those pipelines are included in those integration tools. If you're going, let's say, with Matillion 5 transit stream sets, so in the cloud, they can become quite costly, but they can be they can help us to easily, let's say, prototype, not just prototype, but make production ready data transformations. They're quite easy to use. And maybe as the last and really, let's say, interesting option is are the SQL orchestration frameworks. But SQL orchestration frameworks, from the naming of let's say, so from the naming, those are the frameworks that can handle just transformations that are expressed in SQL. So this means that if you're having our data in I don't know, in some MySQL database, those kind of frameworks will not help us. So we'll have to develop some kind of an extraction that is not part of this framework, but from the outside. But if you're having, let's say, all the information stored in a SQL supported database, then we can easily use this kind of framework, and yeah, they're quite flexible, because on top of, let's say, on top of those SQLs, we are having an option to write some custom code in Python, or in data form we can use JavaScript that can make, let's say, this orchestration of those SQL statements a little bit easier. So this is a topic that we can discuss maybe a little bit more in the next sessions, but maybe the core takeaways, let's say, when building analytics environment, is that there are no shortcuts to quality insights, and we have seen that dashboards and, let's say, some data science model are just the last step in this journey. But there are a lot of, let's say, other hidden, let's say, activities that we should handle and that we should take care of. And it's like yeah, it's quite a long journey, let's say, to have quality data and and data that is easy to be consumed. And maybe just as the last thing is that this environment is evolving really rapidly, and yeah, maybe a lot of practices can be somehow can be used from, let's say, established, let's say, practices that we find in data management and data warehousing. So there are some really good approaches there, and yeah, they will help us, let's say, to better manage our analytics environment. So yeah, this is from my side.
Thank you so much, Matej. That was really great, and that's a lot of interesting approaches. I just want to say that our poll is now open, so you can now cast a vote for Matej's feedback of this session. And of course, we have a couple of questions that have come in through different channels, so I'm just going to open them right up. All right, so can you elaborate on monitoring? Does it make sense to run periodic sanity checks over your data? And are there any specific tools in the data ecosystem for that purpose?
Yeah, this is a really great question. And data quality is something that we're always facing those problems. And generally, so in the last slide, I mentioned SQL orchestration frameworks. Let's say some orchestration frameworks are having this testing capability built directly inside the framework. So for DBT, let's say, testing is something that can be easily, let's say, done in those frameworks. But otherwise, let's say, if you're building our custom orchestration framework, then oftentimes data quality is just another step in the pipeline development. So we're just making, let's say, another step that is checking, let's say, our currently transformed data with the sources that we are having in our operational systems. So yeah.
Thank you for that. Next up is, any thoughts about how to efficiently work with table schemes and views and get them in version control, data form and DBT, or have everything managed in Terraform?
Yeah, that's really an interesting one, and that's the question that we were addressing in few of our projects as well. So because we are having here the separation of the infrastructural part of it and the data engineering part of it. So one approach would be, let's say, to have, let's say, all this information regarding databases and data sets stored in data form. So which means if you have stored in Terraform, this means that if you're having it in Terraform, we can version control them. And on the side of pipeline development, yeah, definitely. If you're using Dataform and DBT, these are the approaches that we can take to version control the code as well. So yeah, these are the two options that comes on my mind. Yeah.
Thank you. Business stakeholders just love live data. Any general advice on how to go from a batch approach to streaming for large data sets?
Mm-hmm. For large, yeah. So let's say, oftentimes business intelligence users are used to have daily exports, or let's say daily refresh data. Then if there is a need for some kind of operational dashboards with data that is coming in a really fast manner, let's say, into the system, and they should be, let's say, visualized in seconds from their creation, then we can maybe embrace the streaming, let's say, options. So we can maybe implement some kind of messaging system and then use let's say frameworks like Spark Streaming on top of those messaging system to transform this data in a near real time fashion.
Cool. I'm just wowed by all the information at once here, but that's an excellent presentation, Matej. Could you draw a line between a data engineer and a data scientist analyst? Or is data engineer considered to be more of a data or solutions architect, whereas data scientists and data analysts are more mathematicians / developers?
Yeah. So this is a really hot topic. So who should be a data scientist and who should be a data engineer and software engineer? So I think that maybe we can focus on skills. So if you take a look at a data scientist, her background or his background is mostly coming from mathematics and statistics. So there are a lot of, let's say, calculus, linear algebra there, and so if we don't know, let's say, this kind of concepts, then the models that we're building are just a black box. So I think, at least from my perspective, data scientists should be really interested in statistics and let's say and calculus and so on. Whereas for data engineers, I think that the transition from software engineer to data engineer is not let's say a really big deal, because on both sides we're somehow building software and we are building different layers of software. So a good, let's say, software engineer can, I would say, easily transition, let's say, to a data engineering role.
All right. Thank you. We have some more. I'm going to go with, what's your opinion on data security, encryption in transit / at rest? How to approach this?
Security and privacy, yeah, those are the things that are quite complex ones. So transition. The question was regarding encryption at rest and encryption in transit. So encryption in transit is somehow covered with, let's say, with the communication protocols. I'm not exactly sure, let's say, if the answer is targeting to a specific, let's say, technology, but oftentimes encryption in transit is oftentimes covered with the communication protocols that is somehow having this layer of security around it. Whereas encryption at rest, it really depends. So it really depends if you are managing data ourselves or it's managed by the cloud. But generally, I remember when I was working with Mapr, you're having two options. Yeah, so you can have your files directly stored in a raw format, or you can use an additional layer of security that let's say transform this that encrypts, let's say, this raw information in an encrypted form, and you're having some hardware extensions for that and so on. So, but if there is, I would really, let's say, like to talk about more, maybe, if about this topic. If the question, just reach out to me.
Yeah, I'm sure that everyone is welcome to contact you as well with further questions. And that was actually all the questions we had time for today. Thank you guys so much. And thank you so much, Matej, for doing this session. Everyone, thank you guys for watching today's knowledge stream. Next week's session is Massaging MongoDB Data with Helen Tomek, and our great Mihal will be hosting that. So be sure to check that out on Wednesday, same time and place. So without anything more to add, thank you so much. Have a great day, you guys, and I hope to see you soon.
Yeah, thank you all. Bye.
Thank you.
Đâu